CAV stands for Connected and Automated Vehicles, which is basically automated features that make the vehicle more efficient, such as lane centering, adaptive cruise control, drive through intersections automatically. At EcoCar, the way we test CAVs is really defining scenarios to push their technologies to the limit. So there's a driver monitoring system event that's going to see how teams develop the in-driver monitoring system to make sure the driver's paying attention. Then there's a lateral control evaluation event, which is a test that we set up for teams to demonstrate lane centering on straightaways and curves. And then the big flagship events, the Connected Intersection Navigation Challenge and the ACC feature evaluation to evaluate their adaptive cruise control.
I am the event captain for the Connected Intersection Challenge. In this event, the team vehicles are challenged to autonomously navigate a connected intersection that is sending vehicle to everything, or V2X, signal phase and timing and map messages to the vehicle, and they can use that information to design controls to autonomously navigate the intersection. Our systems that help us evaluate the team vehicles is called the Flex Corridor, which consists of a flexible roadside unit that can track the vehicle under test and deploy a scenario which includes a sequence of SPAT messages and map messages depending on the state of the vehicle under test. The vehicle eventually is responsible for consuming this data and deploying its control based on the signal phase and timing at the intersection. For the EcoCar teams, it's really hard for them to find a test facility which has V2X enabled intersections with active traffic light systems. So we enable the EcoCar teams to set up virtual traffic intersections at pretty much any course that they have available near their universities. It could be a test track, it could be an empty street, or it could be a parking lot where they can set up virtual intersections and test how well their system is performing.
The last event is the Adaptive Cruise Control, or ACC feature evaluation. And that's the vehicle that we've used this feature developed at Argonne National Lab called LARS, which stands for the Longitudinal Automated Replay System. And that allows teams to be tested in a repeatable way to evaluate their ACC efficiency. A lot of those features were demonstrated at the CARB event, which is the California Air Resources Board. That's where students were testing Adaptive Cruise Control, or ACC, on the dynamometers in order to test for their efficiency improvements of their ACC controls.
Chassis dynamometer testing is essentially a treadmill for a car. This allows laboratories to operate a vehicle in a controlled lab environment where we can carefully measure things like vehicle emissions and battery energy consumption.
We're trying to see the whole picture, how energy efficient their ACC systems are and how well they operate. Students are getting first-hand experience with cybersecurity, vehicle networking, developing automated control systems, V2X technologies. So they're getting a whole picture on how to design a system from scratch, but also integrate it into an existing stock vehicle, which is really important when you're going to go into the automotive industry. So you're not just building things in a black box, you're building things to work with existing systems.